probability that summarizes the number of trials, when each trial has the same chance of attaining a specific outcome. Alright, now some of the characteristics of this binomial distribution are: 1. It has a probability of success and a probability of failure. It gives the number of trials. Okay, let's look at an example. Now, example 1. 70% of a certain species of tomato live after transplanting from pod to garden. John transplants 3 of these tomato plants. What is the probability of transplanting exactly 2 of the 3 tomato plants live? Now we'll look at this question automatically. That tells us that in this garden, the probability of success, probability that these plants, when transplanted, will live is 70% as probability of success. And if 20% of these plants transplanting will live, then the probability of this transplanting, of these plants not living, will therefore be 100 minus 70%. That is 30% plus 30, that 30% these plants will not live. Okay, now let's look at the question. Let's get to the solution of the problem. Now before we start, let us see, let the random variable of transplanting the plant be x. That is, x can take 0, 1, 2, or 3. Before we go with the solution of this problem, it is very important that we spell out the formula. Now, let's look at the formula of this problem. The binomial distribution, the probability of binomial distribution can be obtained by the probability of x, p of x equals to n combination p to the power 2 times q to the power n minus x, where p here is the binomial distribution, x is a number of times for a specific outcome within the n trials, and we have n combination x. This is the number of combinations. We move now to p. The p we have here is power x. P is the probability of success on a single trial, which is the probability of the plant living after transplanting. We also have pure probability of failure on a single trial. That tells us that if these plants are transplanted, we are at 30% sure that the plants will not live, and n is the number of trials. Now let's get back to the problem. Now, from all this explanation, we realize that the probability of success p, our variable p, is 70%, which can still be written as 0.7. And the probability of failure today, Q, is 1 minus probability of success. That is 1 minus 0.7, that gives us 0.3. The number of trials in this case is 3. And out of 3, we are trying to test 2, exactly 2 out of these 3 plants to live. We now have probability of exactly 2 is equals to probability of random variable x equals to 2 is 3 combination 2 times the probability of success to power 2 times the probability of failure power number of trials minus the minus 2. With this, probability of x equals to 2 gives us combination 3 power 2, combination 3 2 is 3 times this probability, which is 0.49, times probability of 0.3 power 1 gives us 0.3. This therefore gives us the probability of exactly 2 plants to live as 0.441. This simply means that it is certain at 44% that after transplanting these 2 plants, the plants will live. Okay, subsequent videos will be posted at the Education for All Foundation at the website www.weareefa.org. Stay